We don't. Oh my god! I need to change my name. Very nice.
The fuck is that?
हाँ अरे अभी प्लीज मत करो मुझे जाकर चेंज करना है Okay guys, is this fine?
Yes, this is good. This
Live on YouTube.
ठीक है, this is fine, right? I'm audible now.
Yeah, you're audible.
Perfect.
Guys, we're live, so just make sure there is nothing, okay?
Tanish, Just one more thing, एक बार
क्या?
देख ले मेरे को मैं टेक्स्ट आया कि TK Alex has joined your personal meeting room. I don't know what is that about, but एक बार check कर ले please.
Just 1 second.
It's on the group. It's on the group. Doctor.
Good morning, sir.
Morning.
I hope, sir, I'm audible properly.
Good morning, sir. Sir, are we audible?
Yeah, you are audible. Good morning.
Good morning, sir. So, sir, we are live on YouTube. So, whenever you're ready, we'll start our session for today.
Okay, so you tell what others, how many
Yes.
other participants, etc. Please check things are fine.
Yes, sir. Everything is up and ready. We are live on YouTube and we have tons of participants pouring in from all over the world watching your stream. We've got hackers, we've got students, we've got tons of people all geared up, ready to get a lot from this session.
Okay.
So, sir, a few words about you because everybody should know as much as they possibly can. So, good morning, viewers, hackers, and everyone else present here today. We have with us a very, very special guest. Dr. T.K. Alex is an Indian space scientist who was the ex-director of ISRO and was a part of a very, very esteemed member of the ISRO Satellite Center from the year 2008 to 2012 and was a member of the Space Commission. Sir was awarded the Padma Shri in 2007 and the Distinguished Achievement Award of ISRO in 1976 for his contribution for the first ever satellite. Sir was also awarded so many other accolades, and if we probably start mentioning that, we will go on for a very long period of time. Sir has also contributed to the first Indian moon mission, Chandrayaan-1 in 2008. He's also provided guidance to the interplanetary mission, which I'm pretty sure most of you have heard about, Mangalyaan. So, sir, as I said, this is an extremely huge honor for you to be present here with us today. And genuinely, I don't want to take any further time. I'm sure all of us are charged up for this session. So, sir, over to you. And thank you so much for taking out time from your busy schedule for us.
Okay, thank you. Am I audible?
Yes, sir, absolutely.
Okay. Good morning to all participants for this Equinox. Okay, it's a great thing to be along with you participating in this. I haven't participated in such meetings, okay, except that I have come to VIT for taking some classes for the postgraduate students a year back. Really glad that Professor Rashmi Ranjan Das invited me to attend this meeting and your friends, and I had a talk yesterday. I was wondering what is his name, Equinox challenge or whatever it is. So when I look back in the computer, in the Google, I found this is the time in which the sun moves from south to north on the equator crossing. Then I'm sure you are not worried about such thing, whether the sun is moving, etc. Okay, but it is really a good thing. You found out some name which tells you that there is a change in the climate and people are to be happy. This is a good season to be happy. I'm really happy to be along with you for discussions. And space activities, if I look at it, last month I had a very interesting meeting. Okay, we are celebrating the 60th anniversary of the first human in space, Yuri Gagarin. When this space 60th anniversary was there, it was conducted by the Russian embassy in Delhi. I attended through Zoom, similar meeting, and the speciality was one of the members of our first satellite mission, which was the satellite launch from Russia in 1975. I was a youngster at that time, aged 26. I participated along with others, and don't worry about it. All of us were less than 27 years. We had about 30 people there going with a satellite. First time from India. Nobody knew what is a satellite itself at that time. It was really a wonderful experience. We had a good launch. You remember such things during that meeting. Meeting was very successful. Many of the Russian astronauts or cosmonauts participated in that meeting celebrating Yuri Gagarin's first flight. Okay, leave about Russian flights. Let us look at the Indian space program. All of you know from newspaper and literature what all ISRO is doing. So we have launch vehicles called the PSLV, GSLV, GSLV Mark III. They are all different capacity, can take many tons of weight into orbit. Then a small satellite launch vehicle is also being made now. It is called the SSLV, Small Satellite Launch Vehicle. So things are going on in a different sphere of making rockets to take it up. But you must have read in the newspaper, the latest thing is a very, very big launch vehicles by SpaceX. We can carry many people, including up to 10 people into orbit. And um, the plans are there to take people to moon and have a colony there, and maybe future going to have a colony in Mars. So things are going in a larger scale elsewhere, but on a meager scale, ISRO has started the work, but we also are trying to bridge the gap. But because of the finances, we cannot do as much as the very developed countries are doing. But we are doing our part. And we have different type of satellites. You must have read about the satellites. We have satellites for remote sensing. So we sense from the space, looking at the ground, find out what is all the resources available. In the beginning, we had a very low resolution cameras, which is the smallest picture element called pixel. It's only 1 kilometer, so big. That was the pixel when the first satellite launched. But then we had a better optics. The camera optics was improved, systems were made better detectors. Now we could see better than 1 meter resolution. And 2 years back, we launched a satellite which can see even sub-meter resolution, about 30 centimeter objects we can be seen from space. Such techniques have been developed in the country. And it is not only the normal camera, we have radar cameras, what's called as a microwave radar as a camera. So we can see, using that we can image day and night. And that also a very good resolution of 1 meter. And then we have another type of camera called a hyperspectral camera. Normal cameras, we take pictures in 3 or 4 colors, and then we combine it to have a colored pictures. But that is arbitrary, how you select these 4 colors. So we can have more than 4 colors. So it's called a spectral resolution can be improved. So to do that, we have different techniques of splitting the light into very, very narrow spectral bands, what's called as a hyperspectral. So we have cameras which can go up to 256 colors or more, including infrared, we can see almost 300 or 500 colors. So why we want all these colors? Once you have the colors, you can identify the objects very clearly, classify them, find out the agriculture products, minerals, very fine things can be found out from the remote sensing. And then we have stereo cameras. So stereo cameras are used, as you know, some of you are studying robotics. They are used for finding out the 3-dimensional view, or you can find the distances. So we have cameras in the 3-dimensional way. Now the latest thing is in the remote sensing is not just one satellite, a constellation of satellites. So number of satellites have increased very many. There are some US companies who have made 200 to 300 satellites, small satellites launched. Each has got a camera. And so the idea is to have frequent visit of the Earth. Wherever you want, you can look at it frequently. And the requirement given is image anytime on demand. So that type of things have come. You must have seen some images in the newspaper about the Chinese people entering the Himalayas, and the pictures are available in the market. So on a daily basis, on demand, the pictures are available. And we are also not lagging behind. So next month, somewhere, not next month, this month itself, sometime, we'll be launching a satellite called from the Sriharikota launch pad, so which will be positioned in the geostationary orbit that will be always over India, but it's doing not communication but remote sensing. So that means not only once in a day we can take in a one day itself we can take many pictures. So and that also we can zoom on different places and take pictures. So that will be launched this year. So you can imagine the applications of such satellites. Then the other thing is communication satellite. You know, communication satellite through that only all our radio as well as the television transmission takes place. And there also the latest thing is the LEO communication constellations. Almost 1,000, 1,600 small satellites, communication satellite will be launched. They all will be going around the Earth very frequently. But any given time, 2 or 3 satellites will be available. The idea is if you have a geostationary orbit, there is a latency in the signal. If you send the signal, it takes a few hundreds milliseconds for the signal to come back. To avoid that, we have a low orbit satellite, many numbers. So that's a constellation that is already coming into picture. Even in India, the Airtel has got some collaboration to utilize this for internet service through satellite, LEO satellites, where the latency can be in a very few milliseconds, not hundreds of milliseconds. So that is going to come. So that is the new satellite, large numbers of satellite in orbit. But along with that, we have a lot of issues. How do you control these satellites in so many satellites without hitting each other, without interfering each other? How do they communicate each other? They are the problem they have. It looks like they have solved the problem, but it's a control and guidance and robotics people in VIT. Please think about it, how to control not one satellite, 1,000 satellites in orbit, in different orbits, without hitting, they should go each other, they should communicate each other. That's one problem we have to worry about. And there is a good project, we can think about at least a part of it, how to deal with the multiple things. It is similar to the traffic control in a road and multiple vehicles are going, and think about an automatic driverless vehicle going on a road with hundreds of vehicles. How do you control it? With sensing many cars on the road without hitting them, we have to go around. It's a very complex computer problem. So we have to think about solutions to that. So some of them will be very interesting. And we have a satellite called navigation satellite, very similar to GPS. And the Indian version of the GPS is called IRNS, Indian Regional Navigation Satellite. It's a satellite constellation of 7 satellites doing the similar job. And then we have science missions. All of you read about the Chandrayaan-1, Chandrayaan-2 recently. Last year we launched the Chandrayaan-2 that carried a lander and a rover. So a lander did not have a successful soft landing. That also you read in the newspapers. So it's a problem. So a technical problem. People have to think about it, how to have a soft landing. So from a given place in orbit, we have to reduce the speed, come down and look at the ground autonomously, identify the place for landing, and at a very small speed, you have to come and land. How do you do it? What type of sensors you have to use it? So how do you sense the horizontal velocity, vertical velocity, and there are no particular sensors. We have to do some image cameras, and using the cameras, if you get few images, how do you find out the velocity, horizontal velocity, vertical velocity, height, and it is continuously changing. The scale is changing. So this is a typical problem in the robotics, how to have one robotic arm moving from one place to the other one, taking the object, and the algorithms are similar, but the speed at which it has to work for a lander mission is much more complex. And ISRO scientists are working on that. Maybe some of the ideas the youngsters can look at it, how to come from an orbit down and land a soft landing without much of an issue. With a very small velocity, it has to come and land. It's one interesting problem to worry about. Then we have some science missions lined up, even the Chandrayaan-2 and Chandrayaan-3. Mangalyaan already there in orbit. Mangalyaan-2 is on the anvil. We have a plan for a mission to Venus, then a study of the sun uh, called Aditya mission. And that mission will be going in a very interesting orbit. Will be placed in a location between Earth and Sun, where the gravity of both the objects neutralizes. That's called a Lagrangian point, at which the attraction will be almost zero. But how to orbit an object there? So the object will be in what's called as a halo orbit. So it's an imaginary point there, but the object will be going around that. So that is a very interesting thing. It will take place somewhere in about a year's time. And then we can continuously look at the sun and study the sun. The science part of scientists are very keen to look at the sun. And there are very interesting subjects, the control and guidance and robotics, how to talk to satellites. Okay, two satellites are there, one after other. So there'll be a docking port. It's very easy to imagine Russians and Americans, and they have a docking mission. Even 3 days back, some vehicle has gone up and docked with the space station. It looks very easy. But from the control guidance point of view, how do you find out the relative distance between two objects, how to reduce the speed, how to identify the port, how to go and dock it without much of a shock? So these are some areas in which the answers are not fully complete. Look at it autonomously, how to do it. These are some issues. And inter-satellite communication, target identification, soft landing, velocity control. All these things required estimation, control guidance. People know how to do the estimation, what will be the location a few seconds in advance using Kalman filter and advanced techniques. These are some of the areas we have to think about it for the future. Then the new things, what is coming is what's called as the quantum communication, and the communication between satellite and ground. Normally it is by radio means. But new technologies emerging, what's called as the quantum communication, which can have a very highly developed technology of encryption. So the encryption is such that the code cannot be broken by anybody because it's in the optical domain, quantum domain. There are special technology. I suggest students should read about it, understand how we can enable it. And ISRO had done some experiments of sending signal from almost 200 meters distance. And Chinese have sent a signal from ground to a satellite using this quantum communication. They have succeeded. So this is one emerging technology, how to do that in the optical domain. The other thing is the subject which is emerging is the artificial intelligence and IoT. And these are new subjects, but what is the application for these things? So one of the immediate application could be for the remote sensing data. Gigabits of data is being collected for years. Data is in the archives. How to find out information and convert into useful information using AI, historical data, and how the data has been emerging, how a city is growing last 25 years, how cities are growing, what are the requirements, how our forests are areas are increasing or degradation takes place. All this historical imagery can be processed, but the volume of data is very, very large. How to compress the data, how to control, how to study that, it requires enormous computer technology and new technologies must be applied. Now look at the other form is the remote sensing. I am coming back. Remote sensing also there are limitations of the how small you can see it, and there are new technologies what's called as a super resolution. It is applicable to cameras as well as radar imaging, and it is beyond the Nyquist criteria. Nyquist criteria says you can have the smallest resolution, otherwise Nyquist criteria will be defeated. So, but there are techniques in which we can even beat that. Not exactly beating the physical theories, but almost we can go beyond the limit of Nyquist limit of a resolution. That's called as a super resolution. It's a very new subject, not 2-3 years. It is going for last 10 years. It's very popular, but it's being applied in a large scale to improve the resolution of imagery and systems. And now, to think about all these things, now we are in the midst of this COVID, and everybody is worried about it. Okay, why not the students start thinking all these new technology? Why don't you apply it to some of the COVID-related things? Okay, I was talking about satellite or traffic control. Can we control yourself when you are going through a crowd? Okay, can you find out somebody is nearby, whether that fellow have got a COVID or whether he is running temperature? Now you know the temperature sensors are there when you go to a shop. There's a temperature sensor, they measure your temperature. Can we have a temperature? You carry it remotely, can you measure the temperature of all the fellows nearby? So you know the nearby fellows are having fever. You can avoid such places. Or maybe you can find out whether the atmosphere contains some fumes which carries a virus or your bacteria. You can have remotely sense that chemically or by any technique. I don't know the answers, but if you can, somebody can think about it and look at it, and there may be a solution. Right now, using Bluetooth, they try to find out whether the nearby mobile phone person, he voluntarily gave the information that is a candidate or he is carrying virus. That may not be very useful except for some statistical studies. But somebody can find out whether nearby you have any object or whether you can sense these viruses or airborne things by sensing laser techniques or any other techniques. I am not fully no. I myself do not know, but I'm just posing a problem to you. Look at it. Some of them may be applicable. Some of them may be very uh, immediately known to us. But I just in this short time, I did put to your attention what is all going on around the world. The area of space, very interesting subject. Many of the things are what you study in the classes, but they have got applications for the society. And some of them, this finding out how to move in a crowd. That subject is well known for the computer and robotics people. How to avoid collision. Collision-free movement is a known thing, but how to apply that thing to the common subject. One of the subject is train collision, avoiding the two trains coming in the same track, how to detect that and avoid collision. That is many people are working on that thing. I don't think any foolproof techniques have even now come. And if you extend the same thing further, you will find out how to control thousands of satellites in orbit without hitting each other, how to move around, how to sense a satellite which is nearby, and not the immediate detection, but you have to also have an estimation after 1 second what happens, or after a few minutes what happens, will they come nearby, whether collision will happen. So these are the subjects, mathematical subjects to be worked on. For all these things, you don't really have to be having a laboratory. Most of the things can be done on the computer, modeling. So that way you can put up the things. Some of them may not be possible to realize today, but tomorrow it may be possible. So I urge the youngsters to look into all these possibilities, whatever we learned, whether we can put into applications and useful for the society. So with this, I will put a halt for my talk, introducing all the new things in the area of space. Let me wish all of you a safe uh, life wherever you are participating from. And it's a difficult time to go through. Things, I am in Bangalore, things are pretty bad here. I am sure at your location, things may be slightly better. So I will stop at this stage. Maybe I can take maybe a few questions, whether I can listen to the questions, maybe a few of them. I cannot answer to most of you, but some of them are very important. Maybe the moderator can listen to the questions and tell back. Another 5 minutes, I will leave it for that. Thank you.
Yes, sir. We have some questions coming in. I'm going to put some in the chat. Just a second, sir.
Sir, I'll read out the first question till then, which
Yes.
was asked. Sir, somebody wanted you to share your experience with Chandrayaan 1 because you were there in the initial days with them. So, how was your experience with them, sir?
For Chandrayaan 1. Chandrayaan 1 was very interesting, so almost 10 years back. So that was the first time we are launching the satellite to moon. Okay. So the initial launch from PSLV, it went to initially orbit around the Earth, and then slowly the height was increased to reach the moon. Okay, and our rockets are not very big, powerful, as powerful as the Americans or Russians. So we had to fire the small rocket many times to increase the apogee. Apogee means the highest place in the orbit. We going on elongating the orbit. The ellipse were getting elongated, and the calculations should be very accurate, such that when the highest point comes, moon has to be exactly there. So that is the calculations. And there are so many uncertainties about the gravity numbers of the Earth, the moon, and also on the way we have the small thrust coming from the solar energy on the panels that will disturb. So with all this, the calculations very precise. We reached the moon was there, and then we reduced the speed. So go around the moon and reduce the speed and went down and landed. And the most difficult part in that Chandrayaan 1 was not whatever I explained. These are all standard things. We can go to moon, we can have a orbit around, take the pictures. And the most successful thing was we had a sensor which sensed water around the moon. On the moon, but we sensed from the atmosphere water. So that was the biggest discovery of that time. No other satellites found out water on moon. Afterwards, hundreds and thousands of papers have come. Water is there, how to use that water for the future, etc. It has come from including Americans, Chinese. Everybody is now talking about water there. But it was the Chandrayaan 1 discovered water on the moon. That was the biggest discovery. And from the technology point of view, control guidance and the robotics people. So we were in the moon, around the moon, the satellite was going. Suddenly we had some failures. We had a power system had a failure. So that has affected our sensors. The start sensors. Start sensors are used to find out the directions. So we had one sensor initially failed. So we were smart. We said we'll use the second sensor. A redundant sensor was put on. A few months we used that. Suddenly we found the power system again failed in the second one. So we had two sensors failed, main and redundant. So we have absolutely no way to find out our directions. But we have to continue the mission. So mission has to continue, okay, and it has to point to Earth, point to a ground station, put the camera looking down, but we are blind. We don't have camera. If you look at we didn't have idea about the directions. So time was very short. So we looked at different options. When some ideas came from the fundamentals, we looked at the Earth. We looked at the sun was there. We could look at the sun and point one direction to the sun. And we slowly rotated the satellite. And the antenna was looking Earth and going round. Then the antenna picked up the signal from the Earth. Okay, Earth antenna was put on. So once the signal comes, then we got one direction to the Earth. Second direction we got from the sun. So immediately computation was done. We have two direction. We have method of using it. But these are all done not by computer. Most of them were done by hand calculated. Okay, because they were the worst thing we faced. But we made it as a procedure. So somebody looking at the antenna station, looking at when the satellite comes, point the antenna there. The time was noted down, and the time you look at the direction. That technique we used and continued the mission for another 6 months without a formal sensor of direction finding on board. So very successful thing. We could complete the mission. We could imagine, do the imagery of the entire moon, and we discovered water. Many things found, but we look back as a control system, it was a horrible situation where you have the primary sensors failed, but we survived. Okay, next question.
Wow, so that was truly amazing. Even listening to it, oh my God, wow, what an experience. So there's another question in the chat. Sir, can you tell us something about Gaganyaan?
About
So the upcoming mission, the Gaganyaan.
Gaganyaan. Okay, so Gaganyaan is the planned mission to send a human from India. Our GSLV Mark III is the launch vehicle, and it will be launched in a few years' time. So the scientists are working to send the unmanned mission first. So same space module will be put without a man, but there will be a humanoid inside. Okay, a man-like object will be there. It will look like a woman actually. Okay, humanoid will be put. So that will be launched somewhere toward the end of this year or maybe the beginning of next year. I don't know the exact schedules. So that will be going up, and then it will be brought back, and speed will be reduced. It will be falling in the Arabian Sea, and that will be recovered. So unmanned mission will take place. Two of them will take place. So then finally there will be a manned mission, and four astronaut trainees have gone to Russia. They completed the training in Russia. They have come back. They will be trained in India now for the further technical mission, how to enter the space capsule, go there, come back, how do the activities, science experiments. All of the training will be done in the coming years. So this is the overall plan. And there are some scientific experiments also in this mission planned. And later there will be a continuation of this mission, and how it goes, etc., depends upon how the success of this mission, and further activities will be there. Any specific questions on that? I can answer that.
So there's one more question coming up about one of the missions by ISRO. That is, I guess that is a Chandrayaan, the attempt to explore Venus.
Yes. Yeah. Venus mission is already there in the anvil. The project report is ready. So we already decided what type of science mission, science experiments we are doing. The Venus is a very difficult planet. It is covered by very dense atmosphere compared to all other things, compared to Mars and Moon have no atmosphere. Mars have got a very lean atmosphere. Venus has got a very dense atmosphere. Most of them is carbon dioxide, and not only that, it is pretty hot. The surface temperature is 700 plus, so very hot. And we have a mission to go there. And this atmosphere is less than 100 kilometer atmosphere starts and goes down. So the mission is to have somewhere around 500 to 2000 kilometer will be the, I don't know the exact number, it will going around. But through this atmosphere, how to see the ground, that is the main subject. So the sensors are, the primary sensors are radar. Radar that can go through this atmosphere and find out what is the atmosphere, what was on the ground. So there will be two types of radars on that. There's also ground penetrating radar. There are some radars you can see even below the ground level, a few meters. So such powerful radars will be the primary sensors used. And optical sensors are also used extremely very narrow band. So out of the atmosphere, there are very narrow band near about infrared that's open. So through that also you can see the ground. So there will be sensors for that purpose, and also the atmosphere will be studied. What is the content of it, and toward the end, this will be going down and down to the dense atmosphere. It will try to go down, but very difficult to reach because by the time it reaches, it will burn up. Okay, before burning up, whether you can do some experiment, whether you can reduce the speed, and whether you can have a sub-satellite launch from that, a helicopter can be launched from that. That's all discussions going on. But it will be very, very interesting subject. Compared to Mars, it's much more challenging. The dense atmosphere, very hot object. Thank you. Okay.
Sir, we have some questions in the chat. There's one more question. Are there astronaut training facilities in India? I guess there are some enthusiasts.
See, astronaut training center, we had plans but not started. However, we have the uh, Institute of Aviation Medicine of the Air Force is in Bangalore near the satellite center. There they are training the pilots for going to supersonic speeds. They are going. So they have almost similar facilities for going the high gravity testing and all other similar test facilities are available. And similar facilities are being built in ISRO also later. So since we didn't have all the facilities, our trainees were first time sent to Russia, where they have all the facilities, and they were dropped from the helicopter to the ocean, how to survive in the ocean, how to survive in the desert. All those training they have completed. Okay. So, and underwater floating in the water to simulate the gravity conditions, that also they did experiments. And some of them will be developing in this Gaganyaan time, not all of them, but because 70% of the training they have completed there. They also went through aeroplane where you can have a parabolic flight where zero gravity can be stimulated. So that all they completed. Now they will be coming for the technical training here. They already come. The technical training will start anytime. But the astronaut training center, formal training center will be developed in the coming years.
Yes. So there's one more question. Okay, like people want to know your thoughts about SpaceX and the Mars colonization. That is what's the aim right now. SpaceX and the Mars colonization.
Yeah, so SpaceX, as you know, it is they are developing a very gigantic rocket. You can take tons, hundreds of tons of mass to orbit. You compare the biggest rocket ISRO has got, the GSLV Mark III can take only about 15 tons, LEO, not to Mars. Okay. So if you want to go to Mars, the 1.5 tons only you can take. So if you want to take number of people, all their supplies, etc., you need at least about 100 tons to be taken. So the SpaceX launch vehicle, they are planning such massive rockets, can take it and go there. The colonization, different options are there. They are planning to go there. They are not given the time frame, but they will have initially unmanned things going and setting up the things. They deliver the cargo so that the next batch can make use of it. And also they are planning about how to stay, the accommodate, how to stay there. So different type of accommodation studies have been in progress, and it looks like igloos, but not necessarily igloos, but containing things. The biggest problem even in the Mars is the atmosphere is very, very lean. Okay, practically there's no atmosphere. You cannot breathe there. Compared to 760 millimeters of mercury here on Earth, there is only about 7 millimeters of mercury. There's no practically nothing, and oxygen is extremely small. But now the new experiment the Americans have done is even there, can we extract the oxygen from the lean atmosphere? They have succeeded. A few liters have been separated. Okay, once you have oxygen, you can leave it, but the pressure is very low pressure. The living body cannot survive because our blood will boil out. So we need, wherever you stay, it has to be having a atmosphere. You need some gas and a pressure. So these are technical challenges. We have to stay in balloons or contained even on the ground. You cannot just move around without a proper protection. The vacuum like subject. So, but people are thinking about going and living there. So you can see the challenges that they will face. Okay.
So some people, I guess, need guidance on how to enter ISRO and be a space researcher, as a space researcher.
Yeah, we have different ways of entering ISRO. We have what's called as advertisements will come for all India level examinations and followed by interview. That happens every year for the BTech students. BTech is the standard subjects, mechanical, electrical, or electronic computers. So that will be happening every year. Special subject, they have special advertisements will come. Postgraduate students, MTech and BTech interviews are together. For the PhD, those who are PhD, they can directly apply on the website. There's a place where you can register your name, put your biodata, and that will be scanned every month. They will open it and see whether suitable candidates are there, and including foreign. Some students coming from foreign, they can also register there. The registry get opened every month. So, and suitable candidates get called. And if they are found and vacancies are there, they will be taken. And it's a good place to work. Salaries are not that bad, not as much as the private industries, but not bad. A lot of facilities are there. Okay. Government is giving a lot of support. Okay. Medical aid is free, including you and your family. After retirement, also get medical facilities. This time we had to worry about medical facilities much more than any other things.
So even working for SpaceX, that's something like a dream come true, honestly. We have one more question. What advantage will we have over other countries once RISAT-1A is deployed?
Which team?
RISAT-1A. I guess that's a satellite which is supposed to be deployed soon. So the question is, what advantage will we have over other countries once the satellite is deployed?
You're talking about the GI-SAT, which is going to be launched next month.
So can you see the
Yes,
chat?
sir. Yes, sir. That is the satellite which we are talking about.
Yeah.
Okay, so I was mentioning that it's GI-SAT called EOS-03. That is the new name for the satellite. Okay, so that will be launched and it will be placed in geostationary orbit, like a communication satellite. And it has got very powerful cameras. Okay, more than one cameras are there. You can say take pictures in the visible as well as near infrared. Hyperspectral camera is there. You can look at the India, different parts of India, and every 1 hour you can take image. Every 4 hours you want a detailed picture, you can scan very slowly or fast. All techniques are there. You can look at different places. Okay, from that location you can see almost 1/3 of the globe. Geostationary orbit is such that we can image 1/3 of the orbit anytime. So you can turn the satellite to anywhere you like and take the pictures. So the copy is very large.
Yes, sir. So what about the radar imaging satellite, which is supposed to be, I guess, deployed around in June?
Radar imaging satellite we have already in orbit. 3 of them are in orbit.
Yeah, okay. Yes, sir.
Using it's called a SAR, synthetic aperture radar. So those we had RISAT-1 was there. Afterwards now RISAT-2, A, B, C, 3 are in orbit. Okay. So they are the purpose is instead of the light, we use the microwave. Okay. So we use C band as well as X band. C band satellite was there in the beginning. Now they use X band. Okay. So that is to take the images in day and night. You can take images. But image, don't think the image will be the way you take the camera image. It will be mostly black and white image, radar image. Okay, but there are these specific applications for such radar images. Uh, Most of the applications are related to disasters. When the disaster comes, the flood comes, etc., the place will be cloudy. Normal cameras won't work, but these radar cameras can see through the clouds and look at where the floods are there, where the damage has taken place, where the attenuation has taken place. All such images can be taken. They have got military applications as well. So you can look at different places, image different objects. Okay, I mean, even if something is camouflage, so some even under the trees also you can see it. So the whatever applications of a microwave can make use of it.
So
So
that's great, sir. Oh yeah, Kanish, go for it.
yeah, actually, I saw one question. So can you tell like some people want to know about the scientific instruments on board the Chandrayaan?
Yes, sir, because even I wanted to ask this because you were talking about the finding water on the moon and how Chandrayaan was also able to do that. So, sir, more insight on that?
Yeah, yeah. See, um, basically the technology is called as a spectroscopy. Okay. The spectroscopy is you look at an object, you find out the reflected light coming from the object. Sunlight is falling on the object, and the reflected light comes down. And then you scan the reflected light in spectrum. Actually, a spectrum comes. So you look from the visible, ultraviolet, visible, infrared, go on looking at it, and narrow and narrow. So when we come to 3 micrometers, that is the infrared, after red infrared starts, so 3 micrometers, that corresponds to water vapor. So every molecule vibrates at different frequency. So different frequency means different colors, microwave or radar. So that frequency corresponds to molecular frequency corresponds to different colors. That's the principle. So you look at water molecules and hydroxy molecule equal OH. So that has got a vibration frequency around 3 micrometers. It has got other is also about 1.6, 1.8, different, but the 3 is very predominant. So we had a camera which has got ability to go up to 2.95 or something. Okay, not exactly 3. But at that place, if you look at it, suddenly the signal falls. Okay, the normal signal there'll be a dip. It means there is something light is being obstructed by those molecules. Okay, it is wherever there's a dip coming, that means there is such molecules are present. When the spectrogram, you look at it, the dips corresponds to that object. It is similar to you look at anything. Somebody looked at the sun. Okay, using spectrography, they found there is a dip in 1,600 some nanometers, and then found that corresponds to helium gas. So looking at the spectrum of sunlight, you could discover there is helium in sun, and sun is later. That's how it is. Nobody went to sun to find out whether the helium. From sitting on Earth, we could find out the helium. Same technology used. Okay. But the Chandrayaan 2, the same instrument has been improved. That has got more than 3 microns. You can sense more than 3, up to 5 microns. You can see. So definitely, all that water in the near the poles and all the places, all images have been taken. So now the papers are getting published on that thing. They send for the evaluation.
Wow, so that was truly extremely interesting. So this is another personal question of mine. So you told us about your experience with Chandrayaan 1. So any other experience of yours as such, when you look back to it, it is one of the first things that comes
There
to
are
mind.
hundreds of experiences. It will take
Please
much
share
more
a few.
time.
So just a few, sir. Please share a few with us. We really want to know.
Yeah, no, from a technical point of view, going to this Mars mission was one of the toughest things. Okay, that time I was not director of the satellite center. I was still working with the team there. Okay, the thing was the Mars is such a distance. Okay, signal takes 10 minutes. Okay, to from the signal you send a signal, takes 10 minutes to reach there. A response comes after 10 minutes. problem was how to deal with that. Whenever signal, you cannot have a one-to-one correspondence. So all the activities were planned to have automatic operations. But once you have an automatic operation, how to make it foolproof? Okay, so we have a two system, how to make it foolproof. Okay, so that was the challenge of making the system foolproof. Two computers are there. If, two control system, I got two computers. Okay, if which one is correct? Okay, if something goes bad, how to find out if something has gone bad? Okay, so that was the technology developed to have a autonomous operations. So each of the computer will be checking the other one, but it's all health status. And so you between checking them, you can find out what is the which one something goes bad. So you put off that particular thing, use the other one, but then the second one goes bad, what will happen? Okay, so this type of questions will come. So the thing is, once you put off, don't forget about it. Once again, switch on and see whether it still works. Okay, keep on doing that thing till that fellow become healthy. Or so there are options possible, but that's still not foolproof. So these are some challenges in the control and computer systems. Now, when you look at our Gaganyaan mission, same subject came into discussion. Two computers, one computer cannot monitor the other one, second one cannot monitor the first one, there will be a flaw. So the system with a dual redundancy, it won't work. So the idea was, why not you have three computers? Okay. And take a majority. Three computers are there. Majority voting has to be done. The majority success goes. Okay. Still, to any one of them fails, what happens on the way? We have a man sitting in that. So we cannot survive with just two computers. Again, back to square one. Okay, so now the discussion was, why not you add one more computer, four computers. Okay, it's called a quadrupular computer. So I suggest that youngsters start working on this same problem. We have one computer, it crashes. Okay, can we survive with the second computer? Second one crashes, how to do that? So we are now going with the quadrupular computers and some places with three computers. Okay, so there is a mix of two, 3 plus 4. There are two types of designs, but still problems are there. Who will monitor this? Okay, between how to monitor, how to find out a computer is not working, identification of problem, how to recover from the problems. These are some issues. Computer software network people is a very good subject to discuss. A lot of almost the last 2 years, ISRO scientists are working on and debating triple versus quadrupular, how to configure that, how to wire it, not only computer, all system, solar panels, battery, two batteries, three batteries, four batteries, okay, sensors, one star tracker, 2, 3, 4. Okay, so these discussions were there. When you increase it, the weight increases. Okay, whether you cannot carry that. Okay, so there are very interesting topics. Maybe some youngsters and look at it, how to improve the reliability. Once you increase the number, not necessarily reliability increases because additional circuits come, that reliability also goes down. So we have to worry about overall. Some subjects of interest. Okay.
Yes, sir. So, I mean, this was really interesting to hear, but that's all the questions from our side.
Okay, it was very nice to listen to you. Okay, there we can spend some time and come to VITs. Maybe I can meet some of them. They used to
Absolutely,
come
sir.
for the sensor technology MTech courses. I was taking classes. Okay, now last after the pandemic, I not come there. Maybe good thing I could meet some of you online. Very nice meeting and talking to you.
So,
Thank you.
thank you so much for your time. So, thank you so much for this session. It was so interactive and we all learned so much. And so, actually, hopefully, maybe sometime in the future, we get to see you in campus as well. So,
Okay, thank you. Thanks a lot.
thank you so much, sir.
Thank you so much.
Okay, let me thank
Thank you,
all
sir.
of you for inviting me for this all interaction, and Professor and your coordinators and yourself, Stuti, okay, Ganesh, others I cannot see on my monitor, all others working behind it, and all success for your further today's activities.
Thank you so much.
All the best to all of you.
Thank you, sir.
Thank you so much,
Thank you.
sir.
So bye.
Bye, sir.
Hi, sir.